All right, so 5.1 rational expressions. And really all we're going to do with rational expressions, those are expressions that look like fractions. All we're going to really do is do some more domain type work with these. And y'all have already done domains with rational expressions in the past. The only difference is now we're going to put x squared terms on the bottom and figure out the domains, okay? So first I'm going to do a little factoring review. So the first thing I'll review for factoring is what we call a GCF, which is the greatest common factor. So that's the first thing I look for when I factor is, does it have a greatest common factor? So some examples of doing that would be x squared minus 2x. The greatest common factor of these two terms is the largest factor that it got in common. So this one's basically nothing but two x's. This one's a 2 and an x. So the greatest common factor they got in common would be 1x that they both have. So to factor that GCF out, you would write the x, which is the greatest common factor, followed by parentheses. In the parentheses, you put the quotient that you get when you divide both of these terms by that x. So the x squared divided by x. Remember, there's not an exponent here, it's like a 1. So basically, you're just subtracting exponents. So 2 minus 1 leaves you 1x minus 2x divided by that x. The x's would cancel, and all that's left would be the 2. So this would be what we call factored form, because I now have factored out the GCF from these two terms. All right, so y'all, I'll let y'all sort of play with this one. I got a 4x to the third minus an 8x squared. So y'all take a guess at what that GCF might be.
4x.
Oh, you're so close. It's
4x squared.
4x squared. There you go. Because 4 and 8, the largest factor would be the 4. And then when you're looking at the x3 and x2, the largest factor would be the x squared. All right, so good job. So let's see if we can finish it off by seeing what's going to go inside my parentheses. So we got a 4x to the third. We divide that by the 4x squared. Well, the 4's cancel. And the x to the third divided by x to the squared will leave us an x. And once again, 3 minus 2 left me 1x. Now over here, 8 divided by 4 will give me a 2. And then the x squared divided by the x squareds, those cancel. So my final answer would be 4x squared times the x minus 2 in parentheses. So that is a little review on pulling out a greatest common factor. Next, I want to go over factoring trinomials. So my trinomials will be like the x squareds plus the x plus a number on them. So I'm going to write my 4 examples down real quick, and then I'm going to show you the rules I follow. So the first one will be x squared plus 7x plus 12. My second one will do x squared minus 9x plus 20. Our third one will be x squared plus an x minus 20. And then my fourth one, x squared minus 7x minus 30. Now, I'm going to factor these, showing you the way that I use the signs to help me. And I'm talking about the last sign and the middle sign. So treat the one like the positive 12. The last sign for that would be positive. The middle sign for the 7 would be positive. So if you sort of follow the rules of the signs, these aren't that bad. So all these will factor into two parentheses. All right, y'all, let me let one in real quick. So these will factor into two parentheses. So my first, you see these first two problems? The last number on both of these is positive. So that's the first thing I look at. What's that last sign of that last number? So since this is positive, here's the rules I'm going to follow. So if the last number is positive, both factors have the same sign as the middle number. So I know if I was doing this first one, since that last one's positive, when I write my two factors, they're both going to be positive like the middle number. Now, when I do number two here, since the last one's positive, they both have the same sign as the middle number. So both of these will be negative when I write them out. Now, that tells me the signs. Now, to get my numbers, I find factors of the last number that add to get the middle number. So y'all, let's play with this one. These are trinomials, so they're going to factor into two sets of parentheses. Now, there's an x squared on these, and the only way to multiply to get an x squared would be for these to both have an x in the front of these parentheses. So now I'm looking for my signs. Remember, that's positive, so I got like signs, and they'll both be like the middle. So since the middle's positive, both my signs will be positive. So now, the trick to finishing this problem is to find factors of the last number, which is 12. Find me factors of 12 that'll add to get 7. So that's the last number that add to get the middle. What y'all think? Factors of 12 that add to get 7.
4 and 3.
4. Oh, sorry. Go ahead.
Y'all got it? 4 and 3, perfect. Then watch this. 4 plus 3 equals 7. It adds to get the middle, and then 4 times 3 multiply to get to 12.
12. No.
Y'all, same thing here. X squared in the front, so that'll be an X and an X. So what do you think these signs will be?
Well, that's 4 and 5. Oh, the sign's gonna be positive because the 20 is positive, right?
Well,
Negative.
but remember, if the last number is positive, like that 20 is positive, both factors have the same sign as the middle number.
Oh, okay. All right.
So make them both negative. Because guess what? When we add them, a negative and a negative will make a negative when you add them. A negative times a negative will make a positive when we multiply them.
So is that related to like if it's like signs, no matter if it's positive or negative, the result is always going to be a positive number? And if so,
So when you multiply,
yeah, when you multiply, yeah. And if it's
that-
a negative number, that would tell you that both signs have to be opposite signs.
yeah, because these two are going to be negative at the end. So when I do those, they will have opposite signs. Good job. Because see, these two numbers always multiply to get that last number.
Would that next one be 4 and 5?
It'll be 4 and 5, because that's factors of 20 that equal 9. Now watch this. Add that -4 and -5 equal -9. But Patrick, like you said, -4 times -5 multiply to get me a
A positive, yeah.
positive 20. So y'all, that's the trick if the last number's positive. Now let's look at these where the last numbers are negative. So if the last number is negative, Factors have unlike signs, so that's what y'all said, right? Now, the only difference is I'm going to find factors of the last number that subtract to get the middle number. Now, I'll tell you, although we say this, we're really adding them. But remember, when you add unlike signs, the rule is when you add unlike signs, you subtract the numbers and get the sign of the larger number. So you're still following that rule. So it's easier just to find two numbers that subtract to get the middle number. Now, here's the difference, because these are unlike signs. So we got to know who to give what sign. So the larger factor. So of your two numbers that you find, the larger factor has the same sign as guess who?
Oh, okay. So it's -10 and +3, right?
So are you looking at this last one here?
Yeah.
Yeah.
Oh, I'm sorry. Yeah, I thought you were talking about that. I'm sorry.
So here's the rule. The larger factor has the same sign as the middle number. So since this was a middle number was negative, when he figured out 10 and 3 subtract to get 7, he made that 10 negative because the middle number was negative and it was my larger factor. So let me see how y'all do on this one. So number 3, x squared again, you got an x and an x. That's a negative at the end, so you got unlike signs. So what factors of 20 when I subtract will give me 1?
5 and 4.
5 and 4. And since the 5 is the larger factor, we're going to make it positive like the middle number, and the 4 has to be the negative. So watch this when you add 5 and -4 equal 1, like that 1x. 5 times -4 equal -20. And you done got this one here, right? He looked at that -30. He put unlike signs. He said the factors of 30 that would subtract and give me 7 were 10 and 3. And since the middle was a negative, he made the 10 negative and the 3 positive. So they still add 3 and -10 to get the -7, and they multiply to get that -30. So we'll be using this stuff when we start finding our domains in a little bit, okay? So now let me show you one where you got to do everything to it. So I've got me a 2y to the third minus 24y squared plus a 72y. Now it's 3 terms like we did, but guess what? That's a y to the third. So that's too big to actually factor. So the first thing you want to do to this is see if you can factor out a GCF. Anytime these exponents are bigger than 2, I'm looking for some greatest common factors. So y'all, what do all 3 of these have in common?
2.
2y.
So 2, and then they
Oh.
definitely all got a y. So what you would do, you would come down and factor out that 2y by dividing everybody by the 2y. So the 2y to the third divided by the 2y, well, them 2's are canceling, and that's going to leave me a y squared. 24 divided by 2 would be a 12. Y squared divided by y would leave me 1y. And then let's see, 72 divided by 2 leaves me 36. And I have 1y that cancels with that 1y. So they're gone. So now notice what you got. You got a 2y out front, your greatest common factor. But now this inside here will actually factor. So bring down the 2y and make this into 2 sets of parentheses. We know what's going in the front of both of these, right?
Y.
So can y'all tell me what signs I would put on both of these?
Negative.
No, they both be negative. Last one's positive. They both the same as the middle. So now the only thing I need is what factors of 36 will add to get me a 12.
6.
Okay, so that'd be what, a y minus 6 times a y minus 6. So when you got a y to the third sitting up here, when you're done, you better have that y down here 3 times, okay? All right, y'all, so that's my little factoring review I wanted to do with you. So that's about to help us in this section. So the 5-1 actual homework starts out, they want me to find all numbers for which the rational expression is not defined. So this was doing stuff that we've done before in order to find domains. What this really means is set the bottom of the fraction equal to 0 and find all those answers that make that happen. Now, on these first two problems, we don't have to write it in domain form. They just want us to find what numbers make it undefined. And the only way to make a fraction undefined is if the bottom of it is a 0. So for the first one, we got 9b squared minus 10 over 14b plus 15. So all we need to do on this one, since that's just a b in the bottom, there's only a single b down here, we're only going to get one answer. Now, when we get b squareds in the bottom, we'll get 2 answers and so on. So what you want to do is set the bottom only equal to 0. And then it's just a matter of solving this for the b. So y'all, we're going to subtract that 15. So now that'll give us our 14b equals a negative 15. And then divide it by the 14 to make that a 1b. So those 14s cancel, leave my b. Y'all, we can't do nothing with that. So we're going to leave that a negative 15 over 14. So MathLab will say, the answer blank will say, the rational expression is not defined for b equals, and then you'll just put in that negative 15, 14. So it's the same as finding domains, okay? Now let's do this one and see what we come up with. Y squared minus y minus 4 on top. On the bottom is a y squared minus 10y plus 24. All right, we got a y squared in the bottom, so that means it's possible. Well, we have to get 2 answers when the y is squared, okay? So we're going to get 2 answers out of that. So we're going to set that equal to 0. All right, let me let one in real quick. All right, so set that bottom equal to 0. So remember, to solve that, we're now going to have to factor that. So in the front, you guess what? You got a y and a y. So y'all, this is on y'all. What 2 signs would y'all put on this?
Negative.
So they're both negative. So last one positive, both the same as the middle. All right, factors of 24 that'll add to get me a 10.
6 and 4.
All righty. So now it's factored. So when we're actually looking for answers, when we set it equal to 0, we got a 0 product rule that says if this factor is 0 times anything will equal 0, and the same thing for this factor. So what we do at this point, we set both of the parentheses equal to 0. You know, just like when you found zeros, and remember when we found zeros, which were actually the solutions, the zeros for the solutions always had the opposite sign than the factors. So you add 6 to solve this. So notice if the factor is negative, the answer was a positive 6. And then this one was a negative factor, but when you solved it, it became a positive 4. So this was just to get you back in shape. The only difference from your first test when you found domains is this test will now use y² type terms so that you got 2 answers you're going to kick out. Now, 3, 4, 5, and 6, the rest of these, we're actually going to find a domain. So we're going to find the domain of each function. We're going to write it in set builder notation. And interval notation. So set builder was when they gave us the fancy parentheses and it said X bar, which means such that X is a real number and X cannot equal whatever. That's set builder notation. Interval notation was using the negative infinity and infinity stuff. So at number 3, the first one they want the domain on is f of x equals 3x minus 7 over x plus 7. So to find a domain, you do the same thing as you found up here for the not defined stuff, because that's the only thing that I need to get out of my domain is numbers that make it undefined. So once again, we set the bottom equal to 0. And we solved that. And y'all, this one only had one step. Subtract 7. So I get x is a negative 7. So set builder notation would be x such that x is a real number. And x cannot equal 7. Now be careful on that because they do have one where they got equals. And if you pick the one that's got equals, it'll mark it wrong. You need the one that says it cannot equal 7. All right, interval notation would be, all of these are going to start at negative infinity. Now, since it cannot equal 7, I got a union around that 7. So your union around the 7, that means it cannot equal 7. And then from 7, we head off towards our positive infinity. So y'all, 1x, 1 union, because you only got one number that you're excluding. So watch this one. G of x equals 5 over 2x minus x squared. So this is out of order, but that's cool because it's got an x squared here. I know I'm going to get 2 answers. Now, since it's not a trinomial, I'm not worried about putting it in order. So what I'm going to do is set 2x minus x squared equal to 0. Now, we don't want to worry about factoring this. What we want to do to that one is factor out that GCF. Because if you notice, both of these have something in common. Which would be the x, right? Both of these have an x. So factor out that x. So that's going to give us an x and then our parentheses. So y'all, let's see. 2x, if we divide by x, the x is canceled and I'm left with a 2 minus, here you had an x squared divided by x, leaves me an x. So I get x times 2 minus x. So set both of these factors equal to 0. Y'all, anytime you factor out an X as the greatest common factor, it's always going to equal 0, okay? Now, the other one, there's two ways you can solve this. The first way, you can subtract 2 from both sides, then divide by that -1. The quickest way would just be to add an X to both sides. So I get 2 on the left side equals my X on the right side. So my two numbers I got to kick out are going to be 0 and 2. So set builder notation, X such that X is a real number. And X cannot equal 0, 2. Now always put mine in order. Because you need them in order when you do the interval notation for sure. So it's a good idea to put these ones in order also. All right. Two numbers I got to exclude, so I'm going to have 2 of those unions. I'm going to start from -infinity. And so I'm going from the left to the right. First number I would hit going left to right would be 0. So we got a union around that 0. From 0, we would go until we hit the 2. So now we union around the 2. And y'all, that's both my numbers out. So now I go from 2 to my positive infinity. So on your number 4, you're going to be really similar. The only thing that might be different might be that 2 might be a 3, 4, 5, or any other number. So remember, 2 terms, even 3 terms, the first thing you got to look for in anything doesn't have a GCF, okay? All right, y'all, so let's move to number 5. Well, let me flip my paper over. All right, so number 5, same thing, f of x equals 3x squared minus 73 over 5x plus 13. Y'all notice there's only one x under here, no exponent. So we're only going to get one answer on this one. So set that 5x plus 13 equal to 0. So I hope y'all noticed every single problem I've done in this section, I have ignored the top of that fraction, okay? All right, I'm going to start out by subtracting 13. So 5x equals -13. Then we come in and divide by the 5. So x equals a -13/5, which means the only number my x cannot equal in my domain is that -13/5. So x such that x is a real number. And x cannot equal to -13/5. And then remember, interval notation, I would start at -infinity until I hit -13/5. So we union around that. And then the only number I'm picking out, so from here I'm headed towards my positive infinity. So y'all in 5.1, when you do the domain, they better start at -infinity and end with a positive infinity, okay? Ooh, look at this one. On top is an x to the 3rd minus an x squared plus an x plus a 3. All of that over x squared plus 11x plus 24. So y'all, I'll let y'all figure out my factors because I'm about to set the x squared plus 11x plus 24 equal to 0. All right, y'all, so what's going in those parentheses? What kind of signs y'all putting on them?
Be positive.
So they're both going to be positive. So last one positive, they're both positive like a middle number. So get
8 and 3.
8 and 3, perfect. 8 and 3, add to get 11. There you go. So factors of 24 that added to get 11 were 8 and 3. All right, so now we're just changing signs, remember, setting both of these equal to 0. So the first one, I'm gonna get a -8. And on my second one, I'll get a -3. So for the last one, x such that x is a real number. And x cannot equal -8, comma, -3. So put them in order from small number to the larger. And then negative infinity until you hit -8. Union around -8 until we hit -3. Union around -3 till we hit our positive infinity. All right, y'all, so that was 5.1, all 6 of them. And then the support for 5.1 will do some of that factoring like I showed y'all with my signs a while ago, okay? So now we're going to look at 8.5, rational functions. So instead of doing expressions and stuff like that, we're going to get into doing more function type stuff with these. So guess what? The first problems in here in 8.5, they want me to find the domain. But now on these domains, all I got to do is write them in interval notation. So it's sort of picking up, doing the same thing 5.1 did. So the first two, we're finding the domain. So this one has f of x equals x squared over 11 minus x. All right, so a domain problem, so set that bottom equal to 0. All right, I'm gonna solve that for the x. So once again, this one would be easier just to add an x to both sides. And I end up with 11 equals my x. So the only number I'm kicking out in interval notation is 11. So this will go from negative infinity to my 11, union around 11, and head towards positive infinity. All right, so I'm about to get y'all to help me factor this one because this one's going to need factored for number 2. We got 1 divided by x squared minus 2x minus 35. So I'm going to set that equal to 0. So we know that side's going to factor. So I know I got an x and an x. So y'all, what signs are y'all putting on this one?
You'll have a negative and a positive.
Perfect. So what factors of 35 will subtract and give me a 2?
7 and 5.
All right, so 7 and 5. Do you remember which one of them I'm going to make negative and which one I'm going to make positive?
7 is negative.
7 is negative, so the larger number always had the sign like the middle, and then my 5's positive. Good job. So y'all, now I'm just going to set these equal to 0 to get those two solutions. So that was positive, it's going to become negative when I subtract. This one was negative, will become positive when I add. So remember, interval notation starting at negative infinity, we would hit -5 first. So union around -5 till we hit that positive 7. Union around that positive 7 till we hit positive infinity. So that's how 8.5 will start out. 2 problems finding the domains. So now I'm about to give you all some definitions. So have y'all ever heard of asymptotes? I think I'm saying that right. So these are called asymptotes. So I'm going to show you a picture so you sort of have an idea what I'm talking about. So you see these graphs here? You see this one's got these dotted lines going up and down. Those would be what we call vertical asymptotes. They're like little imaginary vertical lines. Now, a horizontal asymptote, if you look at this graph, as it gets further towards infinity, the graph is trying to get to the x-axis, but it never can get there. It'll get closer and closer and closer as you head out to infinity, but it never does get on the x-axis. So that's what we call a horizontal asymptote. It's like an imaginary line that is horizontal that the graph tries to approach. So vertical asymptotes are vertical, horizontal will be a horizontal type. So let's start out with the first one, which will be a vertical asymptote. All right, so it's an imaginary vertical line that occurs where a graph is undefined. So if it comes on a graph where it's undefined, that's some of the stuff we were doing earlier when we found the domains. The only thing that makes a graph undefined is when that bottom is equal to 0, okay? So to find vertical asymptotes, and I'm going to use VA, that's a vertical asymptote. To find vertical asymptotes, set the denominator equal to 0. Because if it happens where the graph is undefined, it's going to be the same thing as those numbers you kicked out of your domain. So they come in the form of an equation. So they come in form of x equals some number. So when you put them in MATLAB, if they don't give you the x equals, you got to put that x equals for your answer, okay? They got to look like an equation. Now, here's something else that can happen with a vertical asymptote. A vertical asymptote can be canceled it can be canceled out if a factor on top matches the factor on bottom. Matches a factor on bottom. So if the top of your fraction and the bottom of your fraction have the same factor, it'll cancel out and it won't create a vertical asymptote. What it does, instead, it makes a hole in the graph if factors cancel out. Okay, so sometimes if you don't know what the factors are because you got a trinomial, well, guess what? You might have to factor the top just to see if any of them cancel out with that bottom, okay? But the big thing about this, to find those vertical asymptotes, we set the denominator equal to 0. Now, the second type of asymptote was a horizontal asymptote. So that once again is an imaginary horizontal line that the graph tries to approach as it heads towards infinity. Actually, as it heads toward positive or negative infinity. Okay, so verticals will be straight up and down, horizontals will be flat across. Now here's the thing about the horizontals. When I did the verticals, I set the bottom equal to 0, but for horizontal asymptote, you got 3 cases. And we look at the degree of the top and the degree of the bottom. So remember, the degree is the highest exponent, okay? So the 3 cases are if the degree of top is higher than the degree of the bottom. So if the degree of the top is greater than the degree of the bottom, then this is the only case where there is no horizontal asymptote. If the top is bigger, say an x to the 4th and the bottom was just the x, well, the x to the 4th is going to keep growing so much faster than the x on the bottom that it'll never make an asymptote. It'll just keep heading off towards positive infinity and stuff like that, okay? So degree of the top is greater than the bottom, no asymptote. Second case, what if the degree of the bottom, is greater than the degree of the top, so number 1 was top heavy, number 2 is bottom heavy. If it's bottom heavy, then the asymptote will be y equals 0. The bigger a fraction gets on the bottom versus the top, if you keep dividing and the number keeps getting bigger and bigger on the bottom, it's going to head towards 0, okay? Now, the third case, so we had the top greater, the bottom greater. What if they're equal? If the degree of top equals the degree of the bottom, then we'll have a situation where y equals a over b, where a and b are lead coefficients of the top and bottom. So what that means is, say I had a 3x squared on the bottom, a 2x squared on the bottom, a 3x squared on the top, 2x squared on the bottom. Well, my horizontal asymptote will be y equals 3 over 2, because that's the lead coefficients, remember, is the numbers in front of those variables, okay? All right, y'all, so now what they wanted us to do for these examples, these start at number 3. So for this one, they want me to list all asymptotes of the function, then graph. Now, there's one question where they ask you for an oblique asymptote. If it asks you for an oblique, we don't really cover those. So always put there is no oblique asymptote. But there's one where they didn't take it out, and that's number 4. So I'll show you how they get the oblique asymptote for number 4. But if you don't feel like doing number 4 because it's still got that on it, once you do that homework, if you'll email me, I'll give you credit for number 4 and turn your grade up, okay? So just whether you want to do it or not. So now for this problem, I got f of x equals 5 over x squared minus 16. So I need to find my vertical asymptotes and my horizontal asymptotes. And then I'm going to show you what I just graph them on my calculator because they'll have 4 pictures they can pick out of. And I just look at the calculator to see which one I want. So to find my vertical asymptote, I take that bottom, set it equal to 0, like it says up here. So x squared minus 16, I'm going to set equal to 0. So y'all, let me pull my camera down a little bit here. Now, you can solve this by factoring. Watch this. In the front, we got an x and an x. So what signs would I put in here? The last number is negative, so what's that mean?
Positive and negative 4.
Oh, good. And remember, since there's not a number in the middle for my x, the middle would be a 0x. So find factors at 16 that subtract and get 0, and that is definitely going to be a 4 and a 4. So 4 and negative 4 give you 0. Well, the x is gone, so it's 0. And then 4 times negative 4 give you that negative 16. Good job. All right, so now let me just change these signs. So I get x is a negative 4. I'm going to get x is a positive 4. So nothing new on finding these. It's the third thing today that we're able to do by setting the bottom equal to 0. So y'all up here, you would have to have x equals negative 4, comma, x equals positive 4. Now it might let you do x equals negative 4, comma 4, but I haven't never tried it like that. All right, now I'm going to get my horizontal asymptote. So y'all, let me ask you this. From a horizontal asymptote, I'm looking at the degree of the top, the degree of the bottom. Is the degree of the top heavier? Is the degree of the bottom heavier, or are they equal?
The degree of the top.
So here's my thing. You're probably looking at that 5, but remember that 5's not an exponent. So technically, if you don't have a variable up top, it's like an x to the 0 is up there. Because x to the 0 is 1, and 1 times 5 is 5. So that's why they don't write x to the 0, because it equals 1, basically. So the degree of the top, when you just got a number, is 0. The degree of my bottom is 2. So 2 is bigger than 0. So this one's bottom heavy. So what we say, if the degree of the bottom is greater than the degree of the top, so this one is top is less than the bottom. So that'd be this one. Whoops, top is less than bottom. That'd be number 2. The bottom's greater than the top. So that means this one would be y equals 0. Anytime the bottom heavy, you're going to have a y equals 0 for that asymptote. All right, now they got 4 pictures. So let me show you how you can find them using your graphing calculator. So I would share my screen real quick. So y'all, I would go in my calculator go to y equals. And that equation was 5 on top, so that'll be 5 divided by, now since my bottom has an x squared minus 16, you gotta put the x squared minus 16 in parentheses. So there's my x, I'm gonna square that, minus my 16. So watch how the graph does it when you got them vertical asymptotes at that 4 and -4 on the x-axis. So we'll hit graph. So you see how it made a U, but over here at -4, that's like an imaginary dotted line going right there that graph cannot cross over. And the same thing over here at the +4. Now, if you look at the graph as you go towards positive infinity, you see how that line is above the x-axis, and it's blocked like that because it means as long as you're going out the x-axis, it's getting closer, but it cannot cross over it, okay? So knowing that, look at that picture, you would pick one of these 4. And so if you notice, A is the only one that had the U like it did in the 2 sides, okay? So that's the trick on those. Just graph it on the calculator, pick one of these 4 pictures and be done with those. All right, so let me click this paper again. All right, so number 4 is the only one that had an oblique, and I'm going to show you how to get that one. If it's got an oblique, it's not going to have a Y or a horizontal asymptote, okay? So number 4, make a star by it. It's the one that did the oblique. This one has a f of x equals 6x to the 3rd over x squared minus 9. So let's find our vertical asymptotes. Set the bottom equal to 0. All right, so let's see. What's going in those parentheses?
X plus 3, x minus 3.
So I guess you're my factor, ain't you? All right, I'm gonna set both into 0. So y'all basically changing the signs. X is a -3. This is going to give me a +3. So I know my vertical asymptotes are going to be x equals -3, x equals +3. Notice this one, the degree on top is a 3. The degree on bottom is a 2. So since 3 is bigger than 2, this one would have no horizontal asymptote because it's top heavy. But this is the only one that has what we call an oblique asymptote. Now, this problem shouldn't have been in here, but to get the oblique asymptote, it's also going to be y equals. So let me see how they're doing it in here. Yeah, they're doing it the same way. So to get the oblique, since it's no horizontal asymptote, you take the top term and the bottom term. You take the first 2 terms that's got your degree in them and you divide them. So 6x to the 3rd divided by x squared will leave you with a 6x. So this is like the slope. So since this is a slope of a +6, you'll notice these graphs sort of go uphill left to right. So let me show you the pictures for those. And I'm actually going to zoom my camera in so y'all can see these. So this one's going downhill. The only way those will go downhill is if this was a -6 on that 6x, okay? Since it's +6x, they got to go uphill. So it's got to be C or D. But notice the differences in C and D. This one, your asymptotes are at the positive and -3. This one, they're setting them over here at negative and +6. So look which one's got the asymptotes where you need them, and it's going uphill for that problem. But y'all, I can guarantee you, you will not see that problem on my test. Now, remember, you could have graphed that, so let me go to the calculator. So I'm gonna go to my y equals and clear that one out. So this had a 6x to the third on top. And then I'm going to divide by the bottom. Now the bottom I got to put in parentheses again because I got an x squared minus 9. So x squared minus 9, close parentheses. And you'll be able to tell when I graph it. Oh, it didn't get out far enough. So, So y'all, it didn't make the upper right part. So let me do a little bit of a zoom on this and just to look at it. So I'm going to zoom it out, number 3. And hit enter. Oh, what's it doing? Well, it's not drawing the whole graph like these have on them. So let me show you. Only part it showed me on the graph was that middle part. So just remember where your asymptotes are, and it's got to go uphill since the 6 is positive. But y'all, they really was supposed to take that problem out, so I'm gonna make sure they get it out of here for next year for sure. Which won't help you all, but if you don't get this one right, email me and I'll give you credit for it. Now, starting at number 5, these examples, they want me to find the vertical asymptotes. All right, so number 5 is this: f of x equals 1 divided by x minus 2 squared. All right, so since it's vertical asymptotes, we're only worried about setting that bottom equal to 0. So you got an x minus 2 squared equal to 0. Well, y'all, x minus 2 squared means that this factor happens 2 times. So this would be like the x minus 2 times the x minus 2 equal to 0. So guess what? Since these factors matter or they match up, I don't have to solve that but one time to get my asymptote. So this will only have one asymptote, but y'all, that's because this one is a multiplicity 2. And remember, multiplicity 2s come down and touch the x-axis. Remember, even when it's touched the x-axis, the odd ones would go all the way through. So y'all solve this. We're going to what? Add 2 to both sides. Get x is a positive 2. So my only vertical asymptote is x equals 2. Now that one, they already give you the x equals. All you do is put in that number, okay? Number 6, find the vertical asymptote. I got f of x equals x minus 8 over x squared plus 6x. So I'm going to set that equal to 0. So y'all, to solve this one, what would y'all do to this thing?
Take out the x.
Oh, good. You would take out that GCFX. Good job. And remember, that's the first thing you got to look for is those GCFs. So y'all, if I factor out an x, I'm going to divide both these by x. That's going to leave me at x plus 6. And remember, anytime you factor out that variable as a GCF, when you set it equal to 0, it's always going to equal 0. And then the second one, when I set it equal to 0, I actually got to do some work to this one by subtracting my 6. So I get a -6. So when you do these, if you get a GCF that is a variable, then y'all better have x equals 0 as one of them asymptotes. And then the second one would be what? X equals -6. All right, y'all, let me let y'all catch up real quick. All right, so moving on to number 7. 7, find the vertical asymptotes.
Your paper's high.
And I'm gonna have to move my camera up, it looks like, ain't it? All right, so find your vertical asymptotes. So f of x is gonna equal x minus 6 over 1 minus x. So set the bottom equal to 0. So the easiest way to solve this one, y'all, would be to add that x to both sides. So I get 1 equals my x. But now remember, when you put in the answer, it's going to have that x equals already on this one. So all you're going to do is put your 1 in the box and be done. All right, same thing. Find a vertical asymptotes. I got a -3 over x plus 4 times x minus 1. So they were pretty good to us on this one because they already got the bottom factored. So since that bottom's factored, I just got to come down and set both those parentheses equal to 0. They've already got it factored. So set each factor equal to 0 and change those signs. So all we're doing now is making this one negative and this one positive. All right, so vertical asymptotes for that one would be x equals -4, comma, x equals 1. So when you're doing them, look and see, are they giving an x equal part, or are they just putting the vertical asymptotes are blank where you got to put them in equation form, okay? All right, y'all, this one will be for y'all to play with. On top, I got an x squared plus 2x minus 15. On the bottom, I got an x squared minus 3x minus 18. So this one's going to be a little trickier because you got a trinomial on top, and I don't know what factors it has unless I factor it. Because remember, it's possible that if you get matching factors on top or bottom, they're going to cancel out asymptotes that are vertical, okay? So first, let's start by finding the vertical asymptotes by setting that bottom equal to 0. So one of y'all want to factor that one and tell me what I would put into my parentheses.
-6 and +3.
Oh, good. Boy, you're rolling today.
I love factoring.
Oh, I do too. Once you learn these signs, it's so much easier. So -18 had unlike signs. Factors of 18 that subtracted to give me 3 were 6 and 3, and she made that larger one negative like the middle. So now we just change our signs. So we'll still have unlike signs on our solutions. They're just opposite around in signs. So now we know the vertical asymptotes, but y'all, I gotta factor that top so that I know if it cancels with either of these factors down here. So if I get an x minus 6 up there or an x plus 3, that means one of these asymptotes will cancel. So guess what? What does my top factor into?
+5 minus 3.
Exactly. Unlike signs, one's positive, one's negative. Factor to 15 that subtracted to give me 2 were 5 and 3. So good job. And larger one had to be positive like in middle. Also, when you add these, 5 and negative 3 better give you a positive 2, okay? But notice there's not an x minus 6 or an x plus 3 up there. So that means no vertical asymptotes cancel. So since none cancels, my vertical asymptote will be x equals that negative 3, x equals that positive 6. So remember, if the top ain't factored and you don't know what factors are up here, like here it had an x minus 6, so there wasn't no way it was going to cancel with the 1 minus 6. But you have to check some of these just to make sure, okay? So let me give you one that actually will have something cancel. So this will be number 10. I got g of x equals x to the third over 3x to the third minus an x squared minus 4x. And we're still finding vertical asymptotes, so I'm going to set the bottom equal to 0 again. So that's the x to the third, so we can't factor that into our 2 sets of parentheses yet. So I got to do one thing first. What's the first thing y'all would do to that as far as factoring?
Take out one of the x's.
Definitely. Anytime you got an x3 and you're doing these problems, get that x out, because it's going to be in every single one of them terms. So y'all, we're going to factor out the x. Take away x from everybody, leaves you a 3x squared minus 1x minus 4, all equal to my 0. Now notice, this one ain't as quick and easy because I got a 3 out in front. So let me show you a method I do. Now, I do know this. I do know my signs will be unlike because that last one's negative. So I know eventually I will have unlike signs. And I'll have some x's up front, but I got to make sure if I get a number in front, okay? So let me show you the way to, because you can't find factors of 4 that'll give you 1. There's another thing you got to do. When you got a number in front, what you're going to do is you're going to multiply 3 times 4. That's going to give you 12, okay? Now, y'all find factors of 12. That'll subtract and give me 1. So I'm still doing the stuff I did a while ago, but instead of just looking at the 4 for factors that give me 1, I'm looking at the product of the first number times the last. I'm looking at those factors of 12 that'll give me 1 if I subtract, and that would be my 4 and my 3, wouldn't it? So you take your 4 and your 3. Now, remember I said the larger factor will have the same sign as the middle. So my larger factor is going to be a 4 is negative and a 3 is positive. But y'all, here's the trick. When you multiply 2 numbers to get that last number, right here, when you get the 2 numbers, you got to divide both of them back by that 3. So it's like you borrowed a 3 to multiply by the 4 to get the 12. But once you find your two numbers that add to get the middle, you got to divide that 3 back out of those. So here's my question. Can you reduce either one of these fractions?
Yes, the threes, you can do one.
So that'd be what, basically a +1 over 1 or something, okay? Or which would be just a +1. So here's the trick. The +1 goes in the factor that was positive over here, so this will be a x plus 1. Now, since this one didn't reduce, the bottom number goes in front of the x, so this becomes a 3x, and then the top number goes to the back. So that becomes a 3x minus 4. So y'all, that's how I do them when they got a number in front. I take the number in front, multiply by the last number. That's going to give me this product 12. Now you use that number 12 to find factors that'll add or subtract to get to the middle number. So this one was negative at the end, so we had to subtract those numbers 4 and 3. So put your signs on your numbers. Now, since you borrowed this 3 to multiply by the 4 to get to 12, you got to divide it back out at this point and reduce it. But y'all look at this. 3x times x is my 3x squared. 3x times 1 is 3x. Negative 4 times x is a negative 4x. So the negative 4x and the 3x gave me the negative x. And then negative 4 times 1 is negative 4. So to me, if you learn signs when you factor, it's a lot easier than doing all that 4-term polynomial stuff, okay? All right, y'all, these are all factored, so set all 3 of these. Now remember, I had an x to the 3rd, so I'm supposed to have 3 x's. So set them all equal to 0. Remember, the GCF x always gives me 0. And then I'll just solve the rest of these. So the middle one, you're going to subtract 1. You get a negative 1. The last one, we're going to add 4. Then divide by 3. So that one gives me x equals a 4 over 3. So let me ask y'all this. Now notice, the answer is opposite in sign than this fraction was right here. My fraction was a negative 4/3. My answer was a positive 4/3. This fraction turned into a positive 1. The answer was a negative 1. So y'all, let me ask you this. Did any of these 3 factors cancel? I got an x plus 1, and 3x plus 4. So what's this x to the 3rd tell me on top? It basically tells me I got an x times the x times the x, right? So now that we know this is x times x times x, did any of these 3 factors cancel with an x? Well, y'all, there's an x right out front, right? This x out front will cancel with one of these x's. So since I was able to cancel out one of these factors, this asymptote right here is canceled out. And what it'll do is it'll make a hole in the graph. It won't do that vertical line. It'll just make a little hole in the graph and keep on going. So vertical asymptote of 0 is canceled out. Since the same factor of x occurs on top. So that means my only vertical asymptotes are going to be x equals the 4/3 and x equals where's the negative 1. All right, so let's do 3 problems where we find our horizontal asymptote, then I'll be done with it. So y'all, these problems will say determine the horizontal asymptote. Now remember, these, I'm looking at the degree of the polynomial. You got three cases: top heavy, bottom heavy, or they're equal. And these will all be a y equals a number. Verticals are x's, horizontals are y. So number 11, f of x equals 3x to the fourth plus 2 over 2x to the fourth minus 3. So look here, the degree of the top is 4, the degree of the bottom is 4. So when they were equal, I said this equaled the ratio of A over B. Because remember, I got the same degrees. Where A and B were the lead coefficients. Well, y'all, my lead coefficients are the 3 on top and the 2 on bottom. So my horizontal asymptote will be y equals that 3/2. So when they're equal, now remember, if this would have been x4 on top and a 2x4 on bottom, you at least got to put a 1 in there, okay? So if there's not a number, put a 1. All right, this one's on y'all. You got an x squared minus 3 over 6x to the fourth plus 7. So y'all figure out, is that case 1, 2, or 3? Is it top heavy, bottom heavy? Are they equal? And depending on which one you said, what's the asymptote? Or is it not asymptote? Okay, so let's do this. The bottom is a 4, so the bottom is greater than the top. The top's just a 2. So y'all, I'm just looking at exponents. Since it's bottom heavy, this was what? Y equals 0. Anytime it's bottom heavy, you're going to put y equals 0. That bottom is growing so much quicker. All right, y'all. So the last one I'm going to do with y'all will be this 13. And then we'll finish out. 8.5 has about 2 or 3, but we got to do a lot of work on them. So we'll save that till Wednesday, and then we'll do a short section 8.6. So this one has f of x equals x to the third minus 3x squared plus an x minus 2 all over x squared minus 13. So this one has a degree 3 on top, degree 2 on bottom. So the top is greater than the bottom. So what did I say about that one as far as horizontal asymptotes go?
Is it no horizontal asymptote?
It is definitely no horizontal asymptote. So 100% if the top's bigger, it's going to say no. If the bottom's bigger, it's y equals 0. The only one you got to play with is the one where they're equal. And then it just depends on those lead coefficients out front. So for tonight, you can work 5.1. It was like 6 questions for the actual college algebra. The support had a few you had to factor. 8.5, you can work all the way to number 13, okay? And we'll finish out 14 through 17 come next class. I'll actually be showing you how to use all these asymptotes and stuff to actually graph these by hand. And you'll be able to pick out which graph it is doing them by hand, okay? So Any questions over this?
Where did 8.5 start, if I have that correct?
8.5 started, when I started it, so let me show you where I started it at. So let me go to my screen. So once I finished, oh, let me see which one I used to go. Oh, I was going through 8.5 and I just started it right after the 5.1. But it was still doing the domains. This gets wanted in an interval notation. And then so I did 2 problems and then I got into the asymptotes.
Okay, thank you.
Okay. All righty, so here's the thing. If you haven't done my test, you got to get that test done immediately. And if you don't have access, you're going to have to email me to get access to test 2. But if you don't get that completed, it's going to stay a 0 on y'all. And remember, these tests are worth 50% of your grade at the end of the year. So you don't really want to miss my test. And y'all, we're almost done with test